Hello students, in this video I want to give you a summary of plane kinetics of rigid bodies. The first step, you need to study the kinematics of the rigid bodies, and after that, to start the chapter of the kinetics of rigid bodies, you can watch this short video to have a summary about the topics in this chapter. The plane kinetics of rigid bodies can be categorized in three different groups, similar to the plane kinematics of the rigid bodies. The first group is translational motion. In the translational motion, there is no rotation, the body is translating. This translation can be a straight line or it can be a curved line, but there is no rotation generally in the rigid body. If you write the Newton's second law equation, this is the Newton's second law that we have, and you can write the force equation, and it's equal to the mass times by the acceleration of the mass center. And if you write the moment equation, it must be equal to 0 because there is no angular acceleration and it is equal to 0. So the equation is similar to the equations for a particle. To find the kinetic energy, it's equal to half mvg squared, because there is no angular velocity, so we just have the translational part in the kinetic energy, and vg which is the velocity of the mass center. The second type is the rotation about an axis. In this case, we have a pure rotational motion. So again, if you write the Newton's second law, we have the summation of the force, which is equal to the mass times by the acceleration of the mass center. And in this case, then if you write the moment equation about the mass center, it's not equal to 0 because we have angular acceleration. Or we can write the moment equation about point O, which point O is the fixed point of rotation, and in the right hand side we will have IO alpha, which IO is the mass moment of inertia about point O. If we want to find the kinetic energy, it's equal to half IO omega squared, and IO, as I explained, it's the mass moment of inertia about point O. You also can find the kinetic energy using the general form, which is the half Ig omega squared plus half mvg squared. If you expand this equation and instead of IO you write as a function of Ig, it's equal to Ig plus md squared, and if you substitute and simplify, you will extract the same equation, and this is the simplified form of the kinetic energy. The last type of the motion is the general motion. In the general motion, we have a combination of rotation and translation. In this case, if you write the Newton's second law, we will have the summation of the force is equal to mag, and we can write a moment equation about the mass center, which is equal to Ig alpha. To extract the kinetic energy, we have the general form of the kinetic energy, which is half mvg squared plus half Ig omega squared, which g is the mass center, so this is the velocity of the mass center, and this term is the mass moment of inertia about the mass center. Okay, I hope this video can be useful for you to study the chapter of the plane kinetics of rigid bodies.